let's say you have that older vehicle in your garage, your truck, your SUV, or a car, and you're thinking about breathing new life into it, getting it back on the road. What are you to do? Well, okay, you can rebuild the current powertrain in that vehicle. You can find a crate engine, or you could also electrify it. But it sounds kind of like a daunting challenge, right? How do you know which motors, which batteries, which components to get? Well, this is exactly what this episode of ChargeZilla is all about. Because on this episode, I'm going to talk to Maverick from Legacy EV. He's the expert in this field. And I want to ask him exactly how he picked the components for our electric project, our 1965 Ford F-100 electrification project. So I'm going to cut to some video, me talking to Maverick exactly about how to choose those components and exactly what components we ended up with. How about we start with this? Kind of like why, right? Why we chose the components we chose.
Yep.
And let's dig a little deeper into it.
Yeah. So anytime you build an EV, you've got to source parts from 12 to 20 different manufacturers to make one complete conversion package. So that's what we do at Legacy EV. We combine all those into one kit. And we've got a decision process pipeline, I guess you could call it, we walk customers through to help determine what's going to be the best build for what they're trying to do.
Yeah.
So we can talk a little bit about that today in the F-100.
Yeah, so this is kind of a unique build, at least from my view, because it's a lifted truck on 35s.
Yep.
So it definitely has that kind of tough look to it and tough capability. It has an 8-foot bed, so technically it can work on a ranch, can be your daily driver, can go some trail running, right, off-road. So what, at least from my perspective, what I really wanted it to do, so ultimate range was not my ultimate goal.
Yep.
300 miles of range or more. I didn't want to drive it to work every day. Mm-hmm. Although you could.
Yeah.
But I wanted just enough power, not monstrous power.
Yeah.
Just enough power to go off-road, maybe haul a payload or something in the bed, and have decent range.
Yeah.
I was just curious. Like I saw the truck plugged in. I was like, what am I looking at here?
So it's a 1965 F-100. So it started out obviously with like a straight six engine, and then it was sitting around. It's a long story.
Yeah.
We wanted to see what else we could do with it, so we electrified it. What do you think?
When he said it was electric, I thought it didn't sound electric when you backed it in.
I think it's super cool ingenuity and who'd have thought, to really do it into a lifted 4x4.
Right.
It's pretty cool.
Yeah, I like how you guys left it in the conditioning, so modern and old at the same time.
I'm watching your videos forever. I was
What's
watching
today?
it this morning. I was watching the Lightning versus the Ram.
Diesel?
Diesel, yeah. I was watching it literally this morning. I was getting it ready.
Thanks, dude.
It's pretty cool.
I'm going to continue sort of thinking that that's a thing to do someday.
Do you have a vehicle in mind?
Yeah, a Ford Ranger. Would be for work, for my work. And I just think as a platform, it's sort of the ideal EV. It's small, light.
And you don't drive long distances, or do you?
No, not for work. No.
Okay.
So the easiest place to start when you're trying to spec out a kit for an EV conversion is with the motor. Like, what kind of power do you want? What size power plant do you want? And how are we going to make that work? So in this build, we ended up going with the Hyper 9 motor. And we actually went with 2 Hyper 9. So dual Hyper 9 motors. And we wired them in series, or we connected them in series. So one of the motors is dual shaft. So we've got like the 2 shafts on each end of the motor, and then the other single shaft. So the motors are coupled at the shared shaft, and then they go straight to a gearbox, which is 1.9 to 1 gear reducer, and then to the divorce transfer case.
Yes.
And so the reason we went with the Hyper 9s on this truck was because, one, it's a super small package. Those motors weigh, I think it's 120 pounds, and I've got the spec sheet up, so I'll give specs off the actual page here.
And Hyper 9 is the company that built the motor.
Yep.
So this wasn't repurposed from some other vehicle, salvaged from somewhere. This is like a manufactured motor.
Yeah. These are brand new motors from NetGain. Hyper 9 is the model of motor from NetGain, and these motors produce 162 pound-feet of torque, and they produce, let's look at the horsepower here. I believe it's 130 horsepower, but let's double check. We might have to do a conversion here from kilowatt output.
Well, you can mention kilowatt and we'll convert later.
Okay, cool. Let's see.
Well, hopefully
and you know what? I'm looking at the high voltage system right now. So this may be valuable to know. There's a high voltage variant of the Hyper 9 and there's a standard variant of the Hyper 9. So the standard Hyper 9 is 120 volts at the peak voltage or max voltage.
Is that the one we have?
That's the one we have. We're running off the standard voltage. High voltage Hyper 9 is 144.
Okay.
So I'm going to pull that up real quick.
And people often talk, brand new vehicle manufacturers, GM, Ford, Porsche, etc. They talk about sometimes 400 volt systems. They talk about 800 volt systems. Lucid is talking about higher voltage systems.
Right.
What are they talking about when they mention this architecture?
Yeah. So voltage is like electrical pressure. So you can picture current and volts as kind of two separate measures of electricity that get you kilowatt, which is power, or watt, which is power. So voltage is like the pressure and amps is the current or the flow, the amount of electricity flowing through the circuit. So voltage, if you have a really high pressure system, that's going to get you more power, right? So this is a lower volt motor, but it's still capable of really high current. So it can still output some good power, but that's why we're seeing 130 horse instead of what you might see in the
Porsches out there or whatever.
Right.
Yeah.
Yeah.
Well, it's related to cost too.
Yeah, absolutely.
I mean, if you had a bigger budget, go ahead and knock yourself out, right?
Absolutely, yeah. And size of the package as well. So I guess I never really finished that either. But we wanted to go with the Hyper 9 motors. They're very small packages, 9 inches in diameter, about 13 inches in length. So they can actually get sucked down into the trans tunnel for most vehicles. And so that leaves a bunch of space in the engine bay to create room for powering the car with the batteries.
Yeah.
So that's one of the main aspects of going with Hyper 9s in the system. They're a cost-efficient motor, which is great. And then when you do dual motors, you can double the power. So that's really how we're still able to get that 680-ish pound-feet of torque out of this truck.
Together.
Yeah, together.
Yeah, with both.
Yep.
Yeah. Okay, so, and what combined horsepower would be in the neighborhood of 240-ish, right? 250.
Yep.
So this truck was born with probably less horsepower by a lot and was born with a lot less torque. So I think the power equation is satisfied.
Yeah.
I mean, I think if you look at the need of this vehicle, the use case of this vehicle, this is a not drag strip monster, right?
Yeah.
It's a kind of a daily off-roader.
Yep.
So I think the power is satisfied. So we know the motors, we know the specs.
Yeah.
Now, where do we go from here?
Yeah, so next we're going to spec out the battery system. And the reason we start with motors is because we really need to understand how much voltage we need from the batteries to be able to determine what we want for the battery pack. So we know we have a 120 volt peak motor, and so we want to figure out how many batteries do we need. So in this one, we decided to go with Tesla modules. So these are repurposed 18650 modules from a used Tesla. And these modules are all checked for specs before they're shipped out. So they're guaranteed at 80% capacity and they have all functioning cells. So if you do get a module off eBay or something like that, you might have an issue of a bad cell. And if you have a bad cell, you sometimes have to go in and clip out that cell, or you're just going to have reduced performance from the vehicle because now they're not functioning at the right voltage.
So you have to really know what you're doing.
Yep. Yeah. So before you're buying modules, you want to make sure you're getting modules that are working.
So do you guys at Legacy EV help with that, or how does it work?
Yeah, so we partner with manufacturers that do that. So at Legacy EV, we're product agnostic, meaning we don't pick parts that we're going to represent more over others. We're representing pretty much all the parts that are available in the EV aftermarket, and we're working with a manufacturer who does that process for us.
Okay,
Yeah.
so there's Tesla dismantlers and recyclers and shops that focus on this stuff.
Yeah, that's their job. They go and they find the best deals on Teslas, they check all the modules, and then they sell those to us, and we can get them put into vehicles with our builder network.
Okay.
So yeah, these 18650 modules, there's 15 of them in this car, and we can break down why that's the case and why we went with the Tesla modules as well. So the motor's 120 volts max, and so we need to stack these batteries in series so they can get up to that voltage. So each battery is around 22 volts. So we had to put 5 in there to get up to the 120 max voltage that we're looking for the motor. And then at that point, we put 3 other chunks of those battery banks also in there, but they're in parallel. So now we've got increased amperage. So Series configuration, that's how you stack voltage. And in parallel configuration, that's how you stack amperage in a build. So we're stacking both voltage and amperage to make sure.
So in this case, it's like 5x3, so to speak.
Yeah, it's
Yes,
going
no?
to be, yep, 5S3P, 5 in series, 3 in parallel.
Uh-huh.
Yep. And so those Tesla modules are capable of, I believe, around 100 amp or current discharge peak. And so we're capable of like over 3,000 discharge, which is, this system will never reach that level. This system will pull 1,200 amps peak. It's like
The motors. Well,
yep, exactly.
So the battery is, so to speak, kind of a little bit overspec'd. Is that
Yeah.
fair to say?
Yeah.
For this, and that's what you want. You don't want to underspec it.
Yeah,
You want to
absolutely.
overspec it.
Yeah, for sure. And then the other nice thing about Tesla modules, which is why we went with them in this build, is Tesla modules come with all their coolant lines plumbed into the module, ready to go. So you just have to get coolant hose fittings attached to the outside, and then you have to swap out the Tesla battery management board for a new BMS board that allows you to manage the battery system from your new internal battery management.
Yeah, so it can be reused in another vehicle like this. Yeah.
Exactly, yeah.
Okay, so, and we decided, well, there are two kind of physical modules now, right?
Yeah, yeah.
So there's one bigger one
Yeah.
that's fitting underneath the hood where the engine used to be. And there's another place where we found inside the frame in the back where the spare tire would have been to place the second module.
Yep.
And by module, I mean these boxes.
Yeah.
Not these modules themselves.
Yeah, terminology does get confusing because when we talk about batteries, we've got the cell level. That's your little like double A sized 18650 battery.
Yeah.
Then you got your module, which is all those double A sized batteries connected together. And then you've got your pack. So your full pack.
Yeah.
And what those are, we're calling them battery boxes. So we've got a battery box in the front, which has got 10 modules. And then we've got a battery box in the rear, which is 5 modules. And all of those have their own coolant lines ran to them. They've got their own battery management satellites. So that's how we're monitoring everything down to the cell level for those modules. And that's how we're getting the roughly 80 kilowatt hour pack out of that system.
Okay. And this should take this vehicle, so roughly 80 kilowatt hours, it should take it where as far as distance? I mean, because that's another consideration we have.
Yeah. We need to go test that and see how much it really gets.
Well, that's why we're doing this series.
Yeah.
So we're estimating, 120 miles, 140 miles?
Yeah.
But it depends on the use case.
Yeah. If we're going all freeway, we might be sitting around 100 miles because this truck is going to be like a big old heavy brick moving through the air.
It is kind of a big, very handsome brick.
Yeah, absolutely.
So yeah, totally. But it's now on 35s. It's rolling big tires. So it's not an efficiency focused vehicle by any means, but it's the vehicle that we fell in love with.
Yeah.
Which is why we're building it.
Yeah.
But if you're going slowly, let's say on a gravel road,
Yeah.
depending on up and down, because you're doing regen too.
Yeah.
So you're gaining energy on slowing down and going downhill. Your range may be higher than that. We mentioned regen, and that's part of the management system, right? So let's talk a little bit about the controller and the wiring, I guess.
Yeah.
Of this.
Yeah, and we can talk about the charger too. So when we're talking about trying to spec out a kit for any specific build, we start with the motor and then we try and determine the battery. And now once we have the battery pack size, we can figure out what kind of charge rate are we looking for. So on this build, we've got 2 3 kilowatt chargers, so a 6 kilowatt charge rate. So it's not going to be the fastest charge out there. If we're looking at an 80 kilowatt hour system and a 6 kilowatt charge rate, we're looking at over 10 hours to charge. But this truck isn't going very far, so I don't picture us emptying it out very often. It's going to be sitting with over half full probably most of the time.
Let's say you do a trail run, which is 5 to 10 miles. You're using a lot of energy to climb over rocks, let's say, but you're not using the entire pack on that trip. So, yeah.
Totally. And so now when we're talking about controllers, the Hyper 9 motors have an integrated controller and inverter system. So it's an SME X1 controller and the inverter's integrated into that, which makes it really nice for install because you're not trying to install both a motor control and an inverter. They're one combined unit. So you can see those on the firewall of the vehicle. That's where they're mounted. And then the coolant lines are ran straight to that, so it can make sure the inverter doesn't get too hot. And the inverter converts the DC current from the battery pack to AC 3-phase current for the motor. And then for battery management systems, we've got dilithium battery management with a master control unit. So that controls both the charger and the battery. And that's how we're making sure that the charge from the grid's coming in at the right voltage and amperage. And that's how the discharge from the batteries is going properly to the inverter.
And those are the components you mentioned at the very top. You
Yeah.
know, they come from different manufacturers.
Yeah.
And, you know, how do you put this puzzle together?
Right.
And this is what we're doing right now.
Yep, absolutely. Yeah, so even when we talk about the motor system, we've got the high voltage motor, the high voltage inverter and motor controller. Then we've got contactors, relays, fuses, maintenance switches. And so when you start trying to line all those up, you're like, oh man, where do I get all this stuff from?
Yeah.
And that's really what we noticed at Legacy in the beginning of starting this venture is we need some place to coalesce all these parts, to have one spot where you can come in and get everything you need for a conversion.
Okay, so now we have 101 Motors, the guys over there, Tony, Steven, and team. You saw them kind of strip the chassis
Yep.
on the previous episode. So what they decided to do is take the bed and the cab and the front clip off the chassis. It just lets us know what we're working with.
Yeah.
It's a truck, so it's a relatively simple process, although there was a couple hitches there.
Yeah.
Like removing the steering column that we showed you last time. But now we have a chassis. Now we can clean up the chassis, see exactly what we have. And actually, it's relatively strong. Some surface rust
Yeah.
that we had to take care of. But then, so let's talk about how we laid it out. So, like you mentioned, divorce transfer case. Some people may not understand what that means. It's really cool, actually. So Ford, what they used to do back in the day in their trucks, the transfer case that controls four-wheel drive and also low gearing for slower crawling, it's not attached to the transmission. Was not. It was attached via shaft, and then you have equal length shaft that goes to the rear axle and then the front axle. So that's how the Bigfoot monster truck was born, because you could lift, the suspension and you can put giant tires under it. And so that's a really cool piece of mechanical technology that existed. And we're actually reusing it, like you said, because we're lining up the motors to feed this transfer case, basically.
Yeah, yeah. And that's the beautiful thing about conversions is we're getting to use so much of the vehicle again. And so we're getting to give this old vehicle with a storied past that is awesome a new life with an electric power plant and get to reuse so much of what was already there. Truck still looks like that from underneath. You can still see the driveline.
Yeah, the driveline, the transfer case, the drive shafts. Also, these are heavier duty axles. These were Ford axles that were on the truck. It kind of was a Frankenstein to begin with a little bit because it was a light duty chassis with heavy axles and a heavy engine before. So it was already not an original pristine example, which is why I felt like it was really great candidate for this too.
Yeah.
Right.
Yeah.
And so in the back, we had some space because this truck never had a spare tire underneath. At least when we had it. So we can use that space for a battery as well.
Yeah, totally. Something that Tommy and I were talking about right before this, which was a funny realization, is, the truck has the F-250 frame, then it's the F-100 body, and now it's got a Tesla battery system, and then a Dana motor system from NetGain. So it's like really even more of this hodgepodge.
It's a tapestry of best. How about this? Best of breed.
Yeah.
Do you like that?
Yeah, I do.
So it's best of breed components. A lot of OEMs do this too.
Yeah.
They source a transmission from somebody else. They source an axle, put it together into one package. And that's really interesting. All right, dude. So what I want to do now is actually take a deeper dive into the motor setup. And this will help the builders out there, right?
Yeah. Yeah,
So-
this is our Hyper 9 wiring diagram. This is for the dual motor setup. And this is something that we offer with all our kits, along with a complete installation guide, which is like 280 pages. So I won't even bore you with that, but it is over here on this other window, just in case we wanted to see it.
Ooh.
And you can tell it won't even load because there's just so much info there. But we'll stick with this for now.
Okay, so this is kind of curious because we do have a dual motor setup, like you said. So kind of walk me through some of these components.
Yeah, definitely. Well, we can start over here in the top right. And I guess I won't use my cursor over it because that'll keep changing where it focuses. But we've got the SMEX1 controller in the top right of the diagram. And that's going to be our motor controller inverter combo. So when we looked at the firewall, there's two of those mounted there. And that's what's communicating with the motors and the other peripheral inputs.
Okay.
And so when you look to the left of that, that's really where we have our inputs. So we've got brake pressure transducer. So that's going to be what controls your regen. You got your throttle potentiometer. And so that's what's now controlling your
pedal, right?
Throttle
Okay.
pedal. Yep, and then FNR switch and drive mode selector switch. So forward, reverse, and then neutral. And with this build, actually, you can't see on this diagram, but there's a separate diagram in our install guide on the parking pawl, which is an interesting aspect of this build. That's for the gear reducer or the transmission. So there's a 1.9 to 1 gear reducer at the end of the motors in series, and there's a parking pawl on that's cable actuated. And then the cable actuation is connected to an electric solenoid that when you flick the vehicle into park mode, it actuates the cable to put the transmission into park.
Which is huge.
Yeah.
Especially for an off-road truck.
Yeah. And most EVs don't have a park mode because they're single speed and their transmission is free flowing. So,
Yeah, so that makes a lot of sense. So we mentioned a little bit about the power output, but now let's kind of dive in a little bit more. So there's peak power output, of course, and there's continuous, right?
Yep.
So can we look at that and then go back to the diagram?
Yeah, so let's go over here. This is just our Hyper 9 overview sheet from NetGain Motors. So we can look at all the key specs here. We talked here about 173 foot-pounds or pound-feet of torque. But then we've got 2 motors. So you can double it.
Multiplied by 2.
Yep. So
it's about 350-ish.
Yep. And then you can double it again because we've got a 1.9 to 1 gear reducer at the output shaft of the motor. So we're looking at 680.
High sixes,
680,
approaching 700.
Right. Yeah.
Yeah.
Yeah, absolutely.
And then horsepower is what? About 95 kilowatts, which is about 128-ish horsepower per motor.
Yeah, exactly. So then you can double that. So we're looking at 260 for horse-ish. Yeah.
Okay.
Yeah. And then it's 100 volt nominal. So nominal is its normal operating range. It's normally operating at around 100 volts. And then 750 amps. But peak amps, let's see here.
Oh, current, it says 750 amp.
Yep.
Oh, okay.
There we go. So 750 amps, but it doesn't say if that's peak
nominal
or
or peak.
Yeah. Kilowatt peak is 95. Kilowatt continuous is 38. There we go.
Okay, so then the weight, it also states the weight, which is important. A lot of people are asking us about, did we add weight? Did we subtract weight from this project? Because that matters to a lot of people.
Yeah.
So these motors a piece weigh about 130 pounds. That's according to the specs.
Yep.
Of course, there's a controller that weighs a little bit also.
Yep.
Double that weight for 130 times 2.
Yep.
Still, when you're comparing it to an old kind of steel block or an iron block,
Yeah.
this is not a lot of weight compared to an engine traditionally.
Yeah, no, it's not much at all. And we also have to remember too, this is very lightweight in comparison, but the motor tray that the 2 motors sat on adds a little bit of weight as well. But it also protects the motors from the elements and is important.
And how does that work? Do you guys have your own kind of suggestions on what kind of motor trays to use, or how does that work?
Yeah, so in the install guide, we've got manufacturer specs on how you're supposed to mount these motors into the vehicle. So the Hyper 9 has, you can see right here, there's a billet faceplate with bolt holes. So that's the main mounting point for this motor. But we also offer a cradle that grabs the motor on the back end to hold it from bouncing too much.
Okay.
So on the motor tray, the dual shaft motor is actually held at both ends, so it's got no sway there. But then on the motor in the front, there's a cradle around it that keeps it from moving up and down. And there's all sorts of info on the install guides about how to mount those. And then we also have some motor mounts that we offer that are compatible with these motors as well.
So you don't have to fab something yourself, but you could if you wanted to, but you don't have to.
Yeah. Depending on what kind of build you're doing, we probably have a mount out there for you. But a lot of the builders are fabricating their own mounts because they want to do a unique mounting position.
Okay.
Yeah.
That's fair. And what are those graphs? Is it just kind of like RPM overlay for the power?
Yeah, so this is power and efficiency. So on the left-hand side, we've got power, which is in kilowatts, and then speed for RPM, so rotations per minute, and then color efficiency here. So really what we're looking at is we're at our highest efficiency when we're somewhere around, and we can zoom in to see this a little better here. We're at our highest efficiency. I believe this is around 3,500, I think.
Well, I think that says 1,500, 2,000, 2,500.
Okay, there you go.
Those are RPMs on the shaft of the motor.
Yep, and then lower kilowatt output. That's our optimal efficiency speed right there.
So if this graph, what appears to be, is between 0 RPM and 6,000. So actually, traditional ICE engines, that's the RPM range we're used to.
Yeah.
So this motor is not spinning at like some stratospheric RPM ranges, right?
Yeah, that's right. Yeah, 8,000 RPM is the peak of what this motor's programmed to do.
Okay.
Yeah.
So it's kind of relatable.
Yeah.
We understand that.
Yeah, absolutely. Yeah, it can operate at 8,000, I would say, probably more easily than gas-powered counterpart.
There's not a lot of heavy pistons moving,
right.
right?
Yep. Less heat that's escaping when you do that. But yeah, for sure.
Okay, that's good. Cool, good to know. So now let's go back to the diagram maybe a little bit more and see exactly how some of the other units, controller units that are involved.
Yeah. Yeah, so we kind of talked about motor controller inputs and then outputs with the motor. We've also got contactors there, and then another SME X1 controller for the dual motor, because there's two of them, remember, on that firewall. And then we've got, down below that, we've got some current sensors and some high voltage battery disconnects, all as a part of this high voltage battery system with some fuses as well. So those are really like your safety measures for this high voltage battery pack. And then go below the high voltage battery pack, and we've got the BMS battery management controller and battery management satellites. And so you can see there, that's what's really monitoring the battery system to make sure cells are healthy, they're discharging, and then charging as well at the appropriate rate and voltage and current.
Gotcha. And also in the lower left on the diagram, we have the 12-volt battery. There's the DC low voltage.
Yep.
And then what does it display, the dilithium?
Yeah. So here I referred to the battery management satellites down below the battery pack, and I said battery management controller, but that controller is actually over here in this MCU. That's the master control unit for the EV charge system, EV charge controller, as well as the battery management system. So that really controls everything charge related for the batteries. And the dilithium display is what shows all that to the user in the car.
And that's the one we have in the middle.
Right.
Yeah.
Exactly. So there you can monitor current discharge and recharge as well for regen.
Yeah.
Yep. And then as we're voltage level from the cell level all the way up to the full pack level, and then kilowatt hour capacity and where it's at.
That's cool. And can people choose different displays? How does that work? I mean,
Yeah, you can. So you can, depending on what battery management system you go with, there are different displays. This is the display for the dilithium system. So that's the one that we've included with all our kits. But you can also like wire the fuel gauge to this dilithium display so that the fuel gauge shows what the battery level's at.
yeah, so if you want to integrate further into your classic, if you have a classic vehicle,
right,
if into your gauges, you can do that.
Yeah, absolutely.
Which is cool.
Yeah.
And also, currently on our build, we do have an ignition key, right? And we do have the speedometer is working.
Yep.
So it may need to be calibrated a little bit more, but I think you want full instrumentation, which we have.
Yeah, absolutely. And then if you look at the bottom here, the DC to DC converter, this is one that people ask about a lot. The high voltage battery pack is direct current, DC. And the 12-volt system is also DC. So really all that's doing is it's stepping down that high voltage 120-volt pack down to 12 volts. So you can keep your whole accessory system running the same way. So I was telling you yesterday I was driving the truck and it started to rain. And I was like, oh, man, I hope they wired up the windshield wipers.
Yeah.
And they did. It's all running through the original system, the DC to DC 12-volt, and they worked. And I was able to see through the rainstorm.
Yeah, and then people may also be wondering about like power steering, AC, heat, all those elements. Can you touch on those?
Yeah, let's talk about it. So this truck originally, Andre, just had mechanical steering, right?
Yeah, and also no AC.
Yeah.
So we kind of kept it the way it was born,
right,
so to speak.
Yep, so that's all the same as it was the way that we took it from gas-powered to EV. But there are those options. So you can do power steering, you can do electric power steering. There's tons of options for that. We've got a power steering pump, electric power steering pump that we use. So you can just integrate it into the original power steering. You can also do power steering columns. There's tons of options for that, but we've got options we recommend with each kit.
Yeah.
And then you can also do electric AC compressor for AC, and as an electric heater core as well for heat.
Mm-hmm. So all those creature comforts, are repeatable.
Right.
And that's what we see on some of the production vehicles from OEMs as well.
Yeah, absolutely. Yeah, I drove a Ford Focus Electric, the 2014 model, and it was just like the gas-powered option with just an electric powertrain. And so
it was kind of a conversion, really.
Yeah, it really was. Yeah. Electric AC compressor, electric heater core, all that stuff.
Totally. Yeah, makes sense. And also, like VW did it with the Golf, e-Golf, right? It was basically a combustion chassis and car
Yep.
converted to electricity.
Yeah, and then they just throw all the batteries in the trunk, so then you
Bam.
lose all your trunk space.
Yeah. So, is there more detail here? And also, so can you do additional kill switches? Do people sometimes look into that, or how does that work?
Yeah. So there's a maintenance switch for each battery pack, so you can cut off each battery pack individually, as well as there's a maintenance switch in the cab of the car. So open the driver door and you look near the seat, and you can just cut off high voltage power right there. Each battery pack has its own high voltage fuse, so it'll cut out before anything catastrophic happens in that regard. So yeah, lots of safety measures to follow, which is something that we cover too in like our certified technician training program. So in addition to supplying builders with all the parts, we also have this like education wing that we do, and builders can go and learn the processes, the best practices, and even laws for your state and conversions, because there are new laws coming out around conversions in every state. And so you can learn about all that in our certified technician training program.
And that's very important for safety. You know, God forbid, you know, we're in an accident and something is happening, and the emergency crew has to come in.
Yep.
And they have to know, you know,
Yeah.
where those elements are, you know, for them as well.
Yeah.
So that's really important.
Yeah, absolutely. FMVSS 305 states you got to have orange high voltage wire or whatever. You know, lots
Do you
of
have
laws.
that written on your neck or something?
Absolutely. Yep.
Okay. Yeah, that's really cool. All right. So where do we go from here? Should we look at some battery deep dive?
Yeah, let's take a look at the battery specs. So this is just a quick table with some of the battery specs. I was firing some of these off earlier, but didn't have this in front of me. So we're looking at a 5.2 kilowatt hour capacity in each battery module. And so that's the Tesla module. I'm going to actually pull up a photo of that real quick on another
let's
tab
do
so
it.
we can show everybody what that looks like.
So let's take a deep dive into the battery modules and packs and look inside.
Yeah. So that's what we're looking at. Battery module right here.
Sweet. So so those look like little briefcases, I guess.
Yeah, little bricks.
Little bricks. So how do you combine them? I mean, we talked about series and parallel already.
Yeah.
And these come from recyclers,
Yeah.
so to speak,
Yep.
now, at least right now.
Yeah. Yeah, so these ones come from 057 Technology. They test and validate each system to make sure they're at 80% capacity before they ship them out. And they're actually, I guess it's probably hard to tell how big they are in the pack here, but if you picture a whole bottom of a Tesla, this is how they fit inside a Tesla.
So it's the entire tray bottom of the car.
Yeah, yeah.
So how many is that? 1, 2, 3, 4, 5, 6, 7. So 7 in a row plus the 15th one, I guess, up front.
And I think there's 2 up front because the Tesla has 16.
They stack them.
Yep. So
Okay.
yeah, we're looking at 16 modules right there. So you can picture one module taking up about half the width of a Tesla, and that's now what we've got here in the truck. And so there's 5 of these in that rear battery box, and then there's 10 up in the front battery box to make a total of 15. And then we can go back over to the spec sheet real quick. So you can see the voltage, the max voltage is 25.2 volts.
Per pack.
Per module.
I'm sorry, per module.
Yep.
Yes.
And so really the simple math there is we're taking 120 peak voltage for the motor and we're dividing it by 25.2, and that's where we're getting 4.76.
Or 5 in series,
Yep.
so to speak.
5 in series.
Yeah.
Yep.
Okay. I'm learning.
Yeah.
I'm still learning.
Yep. There we
Okay.
go.
Sweet. So then each of them weighs about 58 pounds. People always ask me about the weight of batteries.
Yep.
Yes, they are bulky. They are relatively heavy as far as components are concerned.
Yep.
And there's also the price, right? They're relatively expensive. So would you say this is the most expensive part of this build?
Oh yeah. Batteries are almost always at least half the cost of the build.
Yeah.
Yeah. Yeah, and you can see on our website here, each module is going for $1,389. So that's $267.12 per kilowatt hour. So that's a pretty good price per kilowatt hour for modules. That's definitely a low market price. Kilowatt hour costs can get up to $600 and $650 per kilowatt hour, which is spendy. It makes a build cost quite a lot.
Yeah, especially if you need any range
Yeah.
of any kind.
Right.
And of course, big manufacturers, GM and Ford, first of all, they have their own factories. They're now starting to produce these. And they have power of scale, right?
Mm-hmm.
So here right now, we don't. It's fair to say, right? We don't have as much scale as those guys.
Yeah, right.
Or purchasing power. For
You're
that
right.
matter.
Yeah, aftermarket is not quite as big as the OEM market yet.
But we're getting there.
Yeah, it's growing. It is growing
Yeah.
like crazy. So that's super exciting.
Sweet. So what I've seen, I saw a build recently done by Mr. Mopar Man.
Yes, Kevin. with the Electrolyte.
Kevin, Electrolyte. And he had a battery. He actually had a Tesla Model S 100D conversion into a 1972 Plymouth Satellite he called Electrolyte.
Yes.
Clever play on names.
Yeah.
And part of the batteries, the Tesla batteries, he actually put on the plexiglass or kind of a see-through panel. I love that.
Yeah.
Because you can kind of take a look inside the powertrain, which is functional, right?
Yeah.
It's right there.
Totally. It's super cool. And that's like kind of an ode back to like hot rodding, right?
Yeah.
Where it's like you got your big block out exposed in the front of the car. And he's
Right,
like,
shaker hood, all
Right.
that stuff.
Yep.
Yeah.
So he's got his batteries out front, but they're not whatever IP66 rated from dust and water ingress. So
Yeah.
he's got to put a plexiglass cover over them to make sure that they're protected from the elements. But
Totally.
yeah.
And this is a climate-controlled battery, too.
Yeah.
I mean, the battery has its own coolant loop.
Yeah. Yeah. Well, we can talk about that too. We've got min operating temp, negative 18 degrees Celsius /0 degrees Fahrenheit.
Mm-hmm.
And then min temp for charging, that's 4 degrees Celsius. Notice there's quite a discrepancy there between discharge and charge. You typically got to have warmer scenarios for
charging.
Yep.
Uh-huh.
Yep. And so then there's the coolant loop integrated, which could also be used as a heating loop. It's been done before. I think actually maybe in Kevin's Electrolyte, he has it made so he can warm the batteries, which would be something.
Which is important. Yeah.
Yeah.
I mean, it's important for charging and also
Yeah.
performance.
Right.
Ultimate performance.
Yeah.
Yeah. Yeah, that's very cool. It depends. So his car, he likes drag racing. He wants to go 300 miles on the charge,
Yep.
which he can do.
Yep.
So he wants all those things. So he made the build to suit what he wanted. Right?
Yeah, absolutely.
Yeah.
Yeah. And it really started back with that same process of like choosing the motor first, right? He wants power, and he wanted it in a small package that could fit on the rear end. He wanted room for batteries up front. So he went with the Tesla LDU, mounted it in the rear, and then chose batteries from there, decided he wanted the 100 kilowatt hour pack, so on and so forth. Yeah.
Yeah. And built, he said something interesting to me. He said he made the EV kit fit his car,
Yeah.
not the car to fit the kit.
Yeah.
That was important to him because he wanted to retain the car, as much as he could, including the interior, including the
Right.
firewall, including all those things,
Yeah, totally.
which is cool.
Yeah. That's great.
All right, so what else about the battery? I mean, I think we kind of looked fairly deeply into it. And one other thing I wanted to ask you. So these recyclers, right? They take these modules, an example of the Tesla, from the same car. Is that important?
Yeah, that is important. You want all the voltage to be the same from all the batteries. So typically, the best way to do that is just get them from the same pack. When people start to source batteries from different packs and they don't balance the modules or the cells, you can run into some serious issues for health of the battery as well as longevity and performance. So funny enough, Kevin from Electrolyte had like 1 or 2 bad modules in his system. And so he took 2 of the modules and hooked them up to a 12 volt fan and let it run for like over a week. So they got drained to the right voltage that they were equal with the rest of his pack. And so then he was able to put those back into his pack and use them. And rather than go through that headache, we typically just make sure all the batteries are sourced from the same car.
Yeah, but also he was able to kind of locate those and monitor and diagnose it, right? Because it sounds easy. Oh, but how do you find those bad modules, right? You see what I'm saying, right?
Yeah. The battery management system, which we can go see this actually in the TFL truck as well, or ChargeZilla. there's a screen on the battery management display where we can pull up a view of all the cells.
Okay.
And it's got the voltages of each, and you can click into each. So on Kevin's car, he had it on an iPad on the display. Yep.
Yeah.
And in the ChargeZilla, it's on that small screen. You can also pull it up on a computer as well.
Yeah, so that's very important. So you can kind of diagnose the issues, right?
Yep, absolutely.
Because people always tell me, modern cars, no matter what they are, or trucks, I can't work on it. It's just a computer. Well, you can look inside of it now, right?
Yeah.
You have access.
Totally.
So you can see what's going on with it.
Yep, absolutely.
Is there more?
I don't think so. I think we covered most of it. I'm sure there's going to be questions in the
Let's
comments.
go poke inside the truck.
Yeah.
Let's go poke around.
This is your new drive mode selector. So this is what's replacing your Prindle in an old EV. We got park, reverse, drive, which is going to be forward, and then neutral. And what's cool about this one too?
You set park.
Yeah. Well, and we can talk about that too, because in most resto mods, you got to get creative in how you're going to get these EVs into park. And this uses a torque box, which has a parking pawl, parking actuator, and it's a system where you flip it into park, and there's an electric solenoid back there, and it basically actuates this cable that puts the torque box in lock position and makes it so the vehicle won't roll away when you're in park.
Here's the torque box. We can see it.
Yeah. So Torque Box by Torque Trends. It's a 1.9 to 1 gear reducer made out of billet casing with a slip yoke.
Yeah.
And you can see, if you look further back on this side, there's a parking pawl or a parking actuator, and that's what puts us into park mode.
I see it.
Yep.
I see it right there.
Yep.
And here we have the original Ford divorce transfer case.
Yeah.
So it's still a four-wheel drive truck. You can see the shaft going forward to the stock axle up there, and the shaft going backwards to the rear. And then I see some other components up here.
Yeah.
What are these?
Yeah, that's an onboard charger right there. So that's how we're gonna get power from the grid to the DC battery pack. And so this is our 10 module box up here. Most of the batteries are up front here.
Yeah.
And then there's the other 5 in the back. And then we've got our high voltage contactors, controllers, inverters, all that right there. And there's actually a plexiglass cover that sits over this as well.
Yeah, because that's also for safety.
Yep, that's also for safety. Yep.
Very safety minded.
Yep.
On the brake.
Yep, on the brake, putting it in drive. And now actually it's in accessory mode, so switching it to on.
Switching it to on. And here's, you can monitor your batteries,
Yep.
right? Your voltage of a single cell.
Yep.
Is that correct?
That's correct.
So 3.8 currently per cell.
Yep. And then we've got the voltage of the pack. So this is a 120 volt pack system when it's peak. These are 4.2 volt cells. And then you can see our amp draw right here. So right now with just the pump sitting here, we're losing about 2.5 amps sitting still. A little bit of creaking.
Yeah.
Got the steel.
So you can kind of see the motor spinning.
You can see it spinning. And then here we'll feel regen coming up to this right-hand turn. I'll let it off a little bit. There you go, that's no brake.
Yeah, you did not touch the brake.
No brake, yeah. Even coming down these hills, I'll end up feathering the throttle just a little bit because the regen's strong, which is good. That means we're getting power back to the batteries. But yeah, I'll get on the throttle a little bit, which seems counterintuitive. Right?
Yeah, let's go left here.
Okay.
And use the frontage road so we're not in traffic. You know,
Yeah.
I don't want to be in traffic right now.
And we might want to pull out a phone speedometer and see what are we actually going, because I don't know that this has for sure been calibrated.
Because it feels relatively fast.
Yeah, we might be going faster. I don't really know. So you can also see right here, we're pulling quite a few amps, 500. We're going uphill and I'm accelerating, so that's a lot. That's a lot of amps. But if I let off the gas, we can coast a little bit, or I should say throttle, huh?
Yeah.
Let off the throttle, we'll coast a little bit.
Well, you know what we could do in just a minute? We could turn around and come down the hill and see how it behaves.
Yeah, totally.
Maybe we can use one of those pull-outs and turn around.
Yeah, that sounds good to me.
So you've built several other kind of show vehicles and other project vehicles along the way, but none like this, like a lifted truck, right?
Yeah, none like this, and we support a lot of builds too. That's mostly what we do these days.
Yeah.
So we've got builders doing different things really all over the country, but this is really the first patina big lifted truck we've done. Yeah.
Okay, so now let me look at the gauges as we're using regen.
Yeah, so that's now amps going back into the system off regen. So that's good. We're pulling a lot of battery back in, and now I'm accelerating, so it's going a little bit negative, and now we're on regen. So the green is showing us, hey, that's power going back into your battery.
Yeah.
Right now it's empty.
And the red is using power, basically.
Yep. Exactly.
Well, there you have it. I hope you found this interesting. I know that I learned a heck of a lot. Yes, a lot of these components cost a lot of money, especially the batteries, but it just gives you another choice, another option. Maybe you have that project with an old diesel that's broken down, that you have trouble with emissions. Well, this gives you another avenue to pursue and explore and check out. So I want to thank Maverick. I want to thank Legacy EV, Fox Suspension, Fox Shocks, and of course 101 Motors for helping out with this project. And also I want to thank our friend David, that's him in the image behind me, for just having a very successful ChargeZilla F100 project. And as always, stay tuned to alltfl.com for everything automotive, one-stop shop right there. And our F100 truck is going to be making some stops at some shows this year, so stay tuned to more information about it and watch for it at your local car show. Well, right now it's based in Arizona, so if you are in Arizona, look out for our orange big Ford.